whatever we don't get done, I will do tomorrow with the other class. So that way we have a full videoed review. I pulled this from a set of resources that I've been somewhat using with you guys, different than what I was using earlier in the year. And I thought it was a really comprehensive review. Make sure that you are, because there's one lesson still left, right? But I figured it was better to do the review together than the lesson together. So make sure you are on async time, or hopefully you did bring async time, because there will be one question at least on this lesson, the alternating series. Okay, so make sure you get that in. I'm not going to go through the alternating series question today. I'll save that for like Wednesday. Okay. That will be the plan. All right. Okay, so let's do this. All right, so on number 1, we have the nth term of a sequence is -1 to the n over n factorial. We are supposed to write the first 4 terms. That doesn't seem so hard, right? So all I'm going to literally do is just start plugging in the term numbers. Okay. So we would have -1 to the first over 1 factorial, which I'm going to write it kind of here, is going to just be -1 over 1, right? So it would be -1. Okay, the second term would be -1 squared over 2 factorial, and 2 factorial is just 2 times 1. So I am seeing 1 over 2. Everybody okay with that? Okay. All right. I'm going to ask you guys about the 4th term, so make sure you're ready to put the 4th term in the chat. I'll do the 3rd term. You guys do the 4th one. Okay, so 1 cubed over 3 factorial. 3 factorial is 3 times 2 times 1. So 3 factorial, so it'd be -1 over 6. Okay, oh, Nate's got the 3rd one done. All right, what do you guys think about the 4th one? What's the 4th term? -1 to the 4th over 4 factorial. What do we get? Nate's saying 1 over 24. What is it? What do my ladies think? Casey says 1 over 24. Madison's 1 over 24. Okay, so 1 over 24. So that literally, that's it. Just plug in the number and list them out. Okay. All right, and then as we know, this limit is extremely important for this unit. So let's see what happens if I plug infinity in. Okay. If I plug infinity in, don't I end up with infinity over the natural log of infinity, which would be infinity over infinity? What's the fancy word for when we get that? What's the fancy word? What do we call that when we get infinity over infinity, or it's not 1, or 0 over 0? It starts with the letter I. And I don't care if you spell it right. Nate says he doesn't know. Anybody know? It starts with in. And this is the great debate, not inconclusive. It's okay. Here we go. It's like Hangman. I'll add another letter. That's the next letter. It's not imaginary, but I like that we're trying. It's on the tip of your tongue. I'm like, this is like the great. It's not indecisive. We're getting closer. It's not incomplete. It's I-N-D-E-T. Ah, there we go. Good job, Madison. Indeterminate. Okay. It's the great math debate. I can remember very clearly being in like a train in like on an afternoon with math teachers, and like most math teachers, the great debate is what's 0 over 0, right? Is it equal to 1? And I just blurted out, no, it's indeterminate. And the guy who was the math coach at the time is like, that sounds like a calculus teacher answer. So it is indeterminate. One thing I want to remind you of, because I know we've got the AP test coming in May. we cannot write this. You can also not write that on the AP test. So when you see something like this, make sure you do your limit separately. We talked a lot about this last year. So it'd be like infinity squared or infinity, and then you do the other one separately. And I know there's not a lot of space, at least in my spot. If you guys wrote it out by hand, that's fine. So it's almost better when you do limits to write them out separately like that, in case it comes out to be indeterminate. And if you want to even write, you know, indeterminate or something, that's fine. That says indeterminate. So I'm going to apply L'Hopital's rule, and you know we always like write that. You don't have to. You just have to apply the rule. So limit as n approaches infinity, the derivative of n squared would be 2n. What's the derivative of natural log of n? It's been a while. What is that one? Make sure you're helping me in the chat because it's part of your grade to help. Okay. That doesn't count, Nate. Thank you. All right, I want to see your own thinking, not an arrow up. That doesn't work. Okay, so 1 over m. So we basically got a fancy fraction there, right? So, or a complex fraction. So we really rewrite that as the limit as n approaches infinity of 2n times n over 1, which would be the limit as n approaches infinity of 2n squared. And then we plug infinity into it, which would just be infinity. So in that case, it was just really mostly a practice of limits. I probably won't do a straight one like that, but it's a good, let's kind of warm up and get our brains moving. Okay. All right. Let's look at number 3. So find the nth term of each sequence and use it to determine whether the sequence converges or diverges. Okay. So we need to rewrite the sequence. And I'm not sure how much of this we did. I'm not sure that but we're going to try. Okay. So basically, I need to look for what's going on with the pattern. Okay. I'm trying to write basically the function that's going on. And I start with the series equals n equals 1 to infinity. And I'm going to try to figure out what's my formula or my function. Okay. This is term 1, term 2, term 3, term 4, term 5, and so on. Okay. I'm going to rewrite this as like 2 over 1. That might help. Okay. So what do you notice about the numerator compared to the term number? So if this is 1, how do I get to 2? This is term 2, how do I get to 3? If this is term 3, how do I get to 4? What do you guys think? What's the pattern that you're seeing? Casey's already got the whole thing. Nice job. Okay, n plus 1 over n squared. Nice work, Casey. All right, so that's the nth term. Okay, I now, in order to determine if it converges or diverges, I need to take the limit of it. So the limit as n approaches infinity, because this is the nth term test, right? n plus 1 over n squared. So do you guys have your orange sheets out? I will explain how we got it, Madison. Well, while I'm explaining, get your orange sheets out in front of you, okay? I don't have mine in front of me. I should. All right, I can actually pull it up on a different screen because I've got like 3 screens now. All right, so let me explain how I got this. So I know that, so what I'm boxing in blue are my term numbers. I have to base my function or my nth term on my term numbers, okay? So I need to look for a pattern on what's consistent between the term numbers and the values of the sequence, okay? So I recognized that my term number was 1, and to go from 1 to 2, I would just add 1. So I'm going to check that out again. My term number is 2. Oh, I erased everything. Okay, my term number is 2. In order to go from 2 to 3, I add 1. My term number is 3. In order to go from 3 to the 4 in the sequence, I add 1. So I'm basically, for my numerator, I'm taking the term number and adding 1. Madison, does that part make sense? I'll explain the bottom part too. But does that part make sense? Okay, perfect. All right, so then I need to look for a pattern in my denominator based on the term number if I can. Okay, so I'm going to look at, I notice that the first one, the term number matches. That doesn't help me a whole lot because the second one, the term number doesn't match. But I recognize that those are square numbers. So if I rewrote them as square numbers, the term number, it's just the term number squared, right? Does that part make sense, Madison? Okay, perfect. All right, we're looking at our limit here now. So I noticed that my numerator, well, technically I'd probably have to do a good old L'Hopital in here, right? There's a couple of ways I could do it. I could recognize my numerator is going to grow smaller than my denominator, or I could apply L'Hopital's rule. I'm going to guess you guys probably went this way, okay? Limit as n approaches infinity. So I would just have 1 over 2n, okay? So when my denominator is bigger than my numerator, what's my limit going to be overall here? Good. So by the nth term test, if my limit is equal to 0, does it converge or diverge? Uh-oh. Okay, let's get out the orange sheet. Okay. Oh, that's not the one. No, that's not the one I wanted. Where's the full classroom? This one. Okay. Let me find the orange sheet. There it is. Okay, let's look it up. Okay, you can have your orange sheet out during the test. Okay, you can't during the AP test, but you can during this. All right, if it doesn't equal 0, oh, we can't use nth term, can we? Because it only tells that it diverges, right? So it didn't equal 0, so so we can't really use the nth term on this one, can we? Because of the way it is. So we'd probably have to use another test, which of course they didn't show me. They just said converges. That was really nice of them in the answer key. It's not, oh, could we use P series, or we could use the BCSD thing, huh? It's not alternating because we don't have the -1. This one wasn't very nice. I'm going to put a pin in this one when we go to the next one, okay, because the next one's nicer. We at least got the thing that it's supposed to converge. Okay, but let me, I'm going to come back to that one and double check why. Okay. P series, it actually would diverge by the P series because it's 1 over n. So I need to look that one up. I need to figure that one out better. Okay, so let me figure that one out because I didn't look at this at the time. All right, this one is better though. So let's take a look at what we think we're doing with this one. Okay. So I'm going to write this on here. Okay. What's the pattern? What's the pattern that you're seeing there? Because remember, we have to write our nth term first. Ignore the 1 for now. Okay. Nate's saying 5 to the n divided by 4. 4 always on the bottom. Okay. Technically, with the n power is affecting the 4. So I think Nate's saying this, 5 over 4 to the n. Yeah, so, and I agree with what Nate said. Everybody make sure you look at what Nate wrote in the chat. For the first term, 5 to the 0 is just 0 and over 4, and so it's just 1. Okay, because you end up getting anything to the 0 power is going to be 1. So I totally agree with that. So, but notice it's starting at 0 versus starting at 1. The last one we started at 1. Okay. All right, everybody okay with the pattern, Madison and Anna? Do you see the pattern? All right, good. Okay. So what kind of series is that? Look at your chart. Either you can, okay, you may explain it again. So I'm noticing that this is, I'm either got to have term number 1 or term number 0. So this is term number 0, 1, 2, 3. So I have to base my function off of my term number, okay? I notice that the term number is always equal to that exponent. So I notice that 5/4 is consistent. So it's just 5/4 to the term number. Anna, are we making sense now? Okay, perfect. All right, so what kind of a series do we have there? Because that's going to help us run the correct series test on it. Ah, geometric. Perfect. Okay, so we need to look at the R. What's the R value? Okay, 5/4. Perfect. All right, so R is equal to 5/4, which is bigger than 1. So again, I want you to go to your orange chart. Okay, you're going to look up your geometric series, and when R is equal to 1, does it converge or diverge? I want to make sure everybody knows where we're looking here. Okay, so therefore diverges, and do me a favor, I might ask on the test how it diverges by which test, okay? So I could make it multiple choice. I could say it diverges by the geometric series test, it diverges by the P series, it converges by one of them, right? Just to try to mess you up. So make sure you understand which series we're using if it's not already indicated. So diverges by the geometric series test. Okay. Let's take a look at the next piece, okay? And we're starting with nth term, though I don't like nth term on letters choice C. I'm not sure why we said that. This is what happens when I borrow things from other people, right? So use the nth term test to determine the convergence, determine whether or not the following series converge. Remember, nth term only can tell divergence. So if it doesn't work, I can't say that it converges. Okay, I have to use a different test. So, and I know looking at B, I would have probably gone ratio, right? But we're going to try to use nth term. So let's start nth term. Nth term, we just have to go ahead and we start by doing the limit as n approaches infinity of whatever our a sub n is. Okay. So I'm going to see what you guys think about this one. What's my limit? What do you guys think? What's the limit of that one? All right, 1/5, good. All right, so that's equal to 1/5, which is not equal 0. So looking at your nth term test for divergence, right? If we're not equal to 0, it diverges. So we would say therefore diverges by nth term. All right, let's look at B. So I'm going to do the same test. Limit as n approaches infinity of n factorial over 2n factorial plus 1. What do you guys think the limit of that one is? What do you think the limit of that one is? Because we can find it right by looking at it. Remember, your factorial is going to act like an exponent. There we go. It should be, right? I've got a 1 hanging out here and then a 2 there, and those become the coefficients in front. So it should be 1/2. All right. Nate, are you seeing it and okay with that? Okay. All right. So I know that that is also not equal to 0. So converges or diverges, guys? Converges or diverges? What do you think? Good job. It therefore diverges by nth term. Nth term. Okay. The next one, if I put infinity in there, right? So let's just kind of say a what if off to the side. So if I put infinity in, I get 0. So because that equals 0, nth term would be inconclusive. So what test am I going to actually run on C? Which test should I, what is C set up for really easily? Oh, our favorite one, right? I think our favorite is usually is the P series. So that is a P series. So I know that this is P equal to P series with P equal to 3. So P equal to 3 is greater than 1. So when I look at P, do I converge or diverge on this P series? All right, nice job. We converge. So converges by P series. Good job. Okay. So the good news is on the good majority of the rest of them, they actually, and this is why I picked this review because of this next part, is they actually tell us, hey, use this test, use this test, use this test. And I'm going to probably do a little mix of that. Sometimes I won't tell you the test, or it'll be multiple choice and say, hey, we talked about that. It diverges by this test. You have to pick which one it works by. Okay. But here it's being very explicit as to which test we are using. Okay. So it says in 6 that we're going to use the direct comparison. And if I'm very explicit, I really want to make sure you understand each one of these tests. So that's why I possibly will do this where I'm very explicit. I don't want to do a gotcha test. I want you just to make sure you understand this stuff. Okay, that's what I need from you guys on this one is, do you understand all these tests? Okay. All right, so we are going to do a direct comparison, which we call that the BCSD, right? Bigger converges, smaller diverges. So what do you think I should compare to in this one? What should I use as my comparison? Okay, Nate's suggesting 1 over n. Is there anything else I could use? Casey's liking 1 over n. So, okay, so still have trouble figuring out what to compare to. Perfect. Okay. So really what I would do is I would try to figure out, like, substitute an n in for like what's inside parentheses. Okay. So I would probably go with 1 over n squared. And when let's do the 1 over n squared, and then we'll go back and look at the 1 over n and decide why we wouldn't use 1 over n on this one. Okay, but that's where I would go first. If that didn't work, then I would probably go back to the 1 over n. Okay. So we're going to compare to that. So I'm now going to try to do my, so what type of test would I use for 1 over n? Oh, sorry, 1 over n squared. Okay, so that's definitely a P series. So P series with P equal to 2, which is greater than 1. So does that mean that my comparison series converges or diverges? Okay, so it converges. So that one is the comparison is a convergent P series. All right, so now I need to make sure that this one, because we've got converges, I need to make sure it's bigger than my original series. So usually we write the word since, okay, and we start setting it up like it's going to be bigger, and then I actually have to kind of figure that out in my brain if it is bigger. So I'm just going to start subbing term numbers in. So I'm going to start by subbing a 1 in, just because I'm going to compare the terms. No, there's no rule for what you can compare to specifically. I'm going to show you why the 1 over n wouldn't work in a minute, Nate, okay? So just let me, it might have come out inconclusive, and that's why it wouldn't work, okay? So just give me a second to finish this with this part, okay? Yeah, and it's this piece right here that's the problem, okay? So there is a hard and fast once we kind of see, and it's this part here that would break the 1 over n part. Okay, so I'm going to try to see, let's see, we've got 1 over, I'm plugging a 1 in. So let's see, 1 plus 3 is 4 squared is 16. When I plug 1 into there, I would just get 1. So definitely it's looking like my comparison series is bigger. Let's go another term just to be sure. Sometimes I have to do a couple of terms to be confident. So I'm going to put in a 2 into here. So 2 plus 3 is 5. 5 squared is 25. 2 squared is 4. It's definitely this one's bigger, right? So since my comparison is bigger than my original, we know that my original series also converges. Okay. I'm going to write over I'm going to erase the next part, but I want you to understand why we couldn't use the other one. Okay, so let's pretend 1 over n. So I'm going to write this down, but I'm going to erase it in a minute. All right, so let's get down to this part, because we know if we used 1 over n, we would have gotten diverges, right? Because that's harmonic. We know the harmonic one diverges. It's also p equal to 1. We know that diverges. So if I compared with this, so if it diverges, it needs to be SD. So 1 over n needs to be the smaller series, okay? So I'm comparing to this guy. All right, so I'm going to put a 1 in. So 1, we already know that 1 plus 3 squared would be 1/16. When I put a 1 into there, I get 1. Okay, so that just failed there, didn't it? It failed right on the first one because this is bigger. So this is bigger, not smaller. So if you get that it diverges, it has to be smaller. Nate, does that make sense? That's why we couldn't use 1 over n. So that was inconclusive. So if you used that and it didn't work, you need to go back and change your comparison series, okay? That's why I don't always just go to 1 over n. I try to, first, I basically take whatever is inside the parentheses. I'm erasing this. Take whatever's there and plop it in for it, and try that first, okay? And then if that doesn't work, try something else, okay? All right, I'm gonna erase this part and see we're at 21. We're at problem 7. Maybe if we can get 2 more in today, maybe. Really good 3. Okay. So the limit comparison test. So I have to do the limit comparison test. I need to find something to compare to. Now the limit comparison test is a little bit more forgiving, right? Than the direct comparison test. So this time we could use 1 over n as our comparison series, okay? So I'm good. Let's try that this time. So compare to, because I'm kind of seeing the 1 over n here, right? I could also use maybe 1 over n to the 3/2 power. Let's go with 1 over n. Compare to 1 over n, okay? So we know that that's a p series. We know that p is equal to 1. So does 1 over n converge or diverge? It diverges, good. Okay, so by limit comparison test, remember what we do is we take the limit as n approaches infinity of 1 over the original series, and then technically we divide by the new series, okay, or the comparison series, or we multiply by its reciprocal. So really this is saying, if I wrote it a little prettier, that we have n over I'm gonna write it just a little bit different. Oh no, I can leave it like this, n square root of n plus n. So my highest exponent here is a 1, because this would be a 1/2. So what's my limit of that? Can you guys tell me in the chat, what's the limit of that? Okay, it's 1. I looked away for a second. All right, so let's go back to our limit comparison test. I'm going to go back to my my orange sheet, right? So if the limit is greater than 0, they either both converge or both diverge. If it's equal to 0, converges the original. So we're in scenario 1. It's bigger than, our limit is bigger than 0. Okay, so we know that that's greater than 0. Therefore, since my comparison diverge, they'll both diverge. So therefore, both diverge. And I know we were probably a little fancier when we wrote our notes, but this will be sufficient enough for the test. Okay. Let's take a look at least one more here. Okay, so let's try nth term. Nth term, I literally just have to do limit as n approaches infinity out front, right? So limit as n approaches infinity of n over the square root of n squared plus 1. Okay, I would probably shortcut this one in my brain, right? Is the 1, the plus 1, going to be super significant when I'm talking about the limit as we approach infinity? Is that going to be a big deal? Good, it's not. So really, I could kind of, and this is not official work, hopefully this would be a multiple choice, okay? Typically series tests are. So they did a lot more work than what I'm looking at the answer key, and they did a lot more official work, but it's kind of like saying n over the square root of n squared, which is like saying n over n, which is equal to 1, okay? Which does not equal 0. So does it converge or diverge by nth term? There, it's right. So therefore it diverges by nth term. All right, I think we can squeeze 9 in, don't you? We'll get 9 done, and then I will make sure we start with number 10 tomorrow in my other class so we can get the rest of them videoed for you. Okay? All right, geometric series test. All right, so for my geometric series test, I need to look at the ratio. So what am I going to use as my ratio? And remember, we always look at the absolute value of the number. So what's the ratio here? Excellent work. 2/3, which is less than 1. Okay, so if it's less than 1, what does that mean? Does it converge or diverge? Converge or diverge on this one? All right, therefore it converges by the geometric series test. And I know I don't probably need to write that because it was obvious, but all right, now there was another part of the instructions. Did you notice that we've skipped over? It says, if possible, state the value to which it converges. The only one I can do that for is a geometric. So we are going to do that. Remember, there's a little formula that we had that S equals A over 1 minus R. So A is our first term. To calculate my first term, I'm going to substitute 1 into this thing. So I would do, so for A sub 1, or A is fine either way, I do 2 times negative 2 over 3 to the first. So that would be negative 4/3. Now I'm going to plug into this formula. So negative 4/3 over 1 minus my ratio, which is technically, for this, you have to use the negative part. So it'd be minus 2/3. For our test, we do the absolute value of the ratio. The ratio was actually 2/3. All right, double negative is going to go positive. So I've got negative 4/3 over 3/3 plus 2/3 is 5/3. I'm going to really shortcut this. These guys cancel. It's negative 4/5. Okay. All right. So please make sure you get this finished. Okay. In addition to video, I will also probably maybe post some answers for you, so that way you can look at it. Make sure you get that last lesson done. Okay. Can you guys tell me, just because I got to confirm this, when's the end of the triad? Is Andy back in class? When's the end of the triad? Okay, good. It's Friday. Perfect. All right. When are we going to actually officially do our test for Unit 10 here, the first part of Unit 10? Okay, Friday. And you guys got to tell me, kind of give me a heads up ahead of time. I'm going to be testing all day that day, because all my other classes are testing that day, retesting that day. So we will look at whatchamacallit. So you got to tell me kind of when you're going to come. I know a lot of you have 6th period that you can come. And Casey, if we have to go after school, you just got to let me know. If you had to pick, okay, I'm not gonna make a decision yet. Would you rather I curve the Unit 8 test, or that I whatchamacallit, or that we retest it? What do you guys think? What would you rather see, a curve? I will apply the AP curve, and Casey wants to retest. And I may do both, I don't know. Anna would rather curve. Madison doesn't know. Okay. Remember, on the curve, so the AP curve that I would apply is if you get a 40% or better, that's like a C. If you get a 60% or better, that's an A. Does anybody want to change their minds or give me an opinion now? And typically, this is the first year I haven't curved in BC like that. I have been curving the past few years. But I know you guys are my first group that I retested all the way through. Nate says curve. Casey, now that I've explained the curve, what do you think? Do you still want to retest, or would you rather I curve it? I think you guys maybe did better than you think you did, like compared to how, because it was a tough test. All right. Refresh your skills. Okay. All right. And I'm not worried. I'm not super worried about the skill refresh, because we're going to do it again all in whatchamacallit. In April and May too, right before the AP test. So let's see how it comes out first, okay? And then we'll make a decision. All right. So here is Andy. It's 6 whole seconds.
Why do plants hate math? Gives them square roots.
He wasn't happy because I made him redo it, and then I made him clean this morning, so he wasn't happy with me. So he missed his tagline and everything. All right, I will see you guys on Wednesday, like the last 20 minutes of the period. I will get this stuff put up for you. Let me know if you need anything else, okay? Let's make our first focus getting ready for the test this week, okay? Any questions, comments, concerns?